Hi, you're welcome to another exciting class, and that's Dalton's law of partial pressure. Dalton's law of partial pressure. I remember back then in SS1, this happened to be one of the longest law in new school chemistry back then. Yeah, I think it happened to be one of the longest, not the longest, but one of them. Okay, it's not like you have your Boy's law that is straightforward, like you have your Graham's law that is straightforward, like you have your Charles law and all of those. So for this, you have to understand something. For example, the law states that if there is a mixture of gas which do not react chemically together, the total pressure exerted is the sum of the partial pressure of the individual gases that makes up the mixture. So I don't know, the law is just there in the head for years now. And so what it's saying actually is that the law says that when you have this, your P total mathematically is equals to your PB is equals to your PC, as the case may be. So where you have the ABC referring to your individual gases, and your PA, your PB, your PC referring to the partial pressure of each gas and all of that. And so your P total therefore become the sum of the individual partial pressure that makes up this mixture that you have here. So, and then we can have our P total therefore again as our P water as one of the formula and our P gas. So you know that usually the standard pressure is 760 millimeter hydrogen, or sometimes you're given something like this, Newton per meter square, or in Pascal. It can also be in Pascal. Okay, take note. Okay, so not only that, you could have this as your P water, as your P gas. You could also have something like this, where you have the partial pressure of gas A equals to the mole fraction, of gas A multiply by your P total. Yes, so take note. And what that means is, if you want to write the mole fraction mathematically, let's express this. So it's like you having your PA, your mole fraction of A therefore becomes A over what? Your A plus your B plus your C multiply by your P total. So this is so important for you to know. And then if I'm considering B therefore will now be what? This. So take note of this. Equals to what? B plus C multiplied by what? P total. If I'm considering that of C, you can tell this will go up. And so you have this, you have this, and you have this. So this will go up. So this is what you have. So let's assume you're given a question, and then in that question you are told that the number of mole of helium, let's say is 0.81. The mole of neon is let's say you have, please excuse me. Okay, so the mole of neon you have, I'm not actually taking note of the calculation. I'm not adding everything, so I should have added. So if you had, let's say 0.81, 0.15, you have 6, you have 9, yeah, you have 0. Okay, so 100,096 So you have 400. So let's say the last one now, your argon is now 0.04. And then these are all in mole. And then you are given your P total to be, let's say 1.8 ATM, 1.8. And you are asked to find the partial pressure of the helium. So if you are asked to find the partial pressure of the helium, it therefore will now be the value of the helium over the value of the helium plus this is equals to what? Multiplied by what? 1.8. So that's what you're going to have. That's what you're going to have. So you can do the same. You can do the same for neon. If it is neon, it's going to be 0.15 over 0.15 plus 0.80 plus 0.04 multiplied by 1.8. You get your partial pressure of neon. You can do the same thing for argon, right? So please take note of that. That's your P total, as I said, if you are considering, is what I said the other time. So, and then your total mole fraction is equals to your mole A plus your mole B plus your mole C, etc. So you can make any of these subject to formula and all of that. So take note of this. So this is partial pressure. There are times to a question will come and they will say, they will give you the SVP. What's SVP? Saturated vapor pressure. And they will give you maybe the SVP at a particular temperature to be 15 millimeter hydrogen or mercury. So they will now ask you to find the true pressure. They must have given you, let's say, the initial pressure and then volume and all that, where they expect you to use your P1, your V1, your T1, your P2, your V2 over your T2. And they will say you should find this pressure. And then this V1, they would have given you to be, let's say, 558 millimeter. So, and they'll give you your final pressure at STP. They'll just say, find the volume of this at STP. So you know that your P2 is 760. But your P1, you might be tempted to use this directly. Don't do it. Minus 15 from it to get your true pressure. Once you are given your saturated vapor pressure, minus the 15 from this value, then you can get your true P1, then you do your calculation. So this is all you need to know about your Dalton's law of partial pressure. Bye.